Welcome back. This is a developer's guide for Windows 10 Insider Preview. I'm Jerry, this is Andy, and we are going to talk about XAML data binding, Andy.
Yep, it's one of my favorite features about working with XAML. We're going to talk about classic data binding, if you like, first, which is the way that we have bound the data in our app to the UI in a declarative way, which is what data binding is all about. But there's some really exciting new features in this area in UWP, which is the compiled data binding. You get a real performance boost out of that. So it's a new take on binding and addresses some of the shortcomings that have been, the criticisms that have been addressed at classic binding. So we're going to look at the two so you can compare them. So first of all, data binding basics. So if you think about displaying some text on the screen, like this text block, or the content on the button, so we've got hello world and click me underneath, you could hard code that text directly into the XAML so that works. You know, obviously that's going to show up on the screen, and that's great. But there's problems with that. It's difficult to change. It's you can't bind that to sort of the data in your app, and so it's a very static way of doing things. It's a perfectly valid way of doing it, but it's not dynamic. It's not something that's going to change as you run it and allow you to have a living app that's living off the data of your app.
So literal data is static data.
It is static data. But the majority of apps, just about every app really, actually works off some kind of data, some collection of data. And we have a model. So this is all about good software patterns as well. So we have a model that we use. MVVM is the name of it. But we have a concept of a special class called a view model, which takes your model, which is the raw data, and then presents it in a way that the XAML UI can actually link to it declaratively.
So a model might be, as an example, a user record or class is a model just for that, but a view model is a class built specifically for a page.
Yeah. So this rather contrived example here is another example of the screen before with the text block, and then below it we've got a button, but in both cases the text that you're seeing on the screen has actually come from some class. So you can see text block, text equals, and then in the quotes we've got binding message. And then the content for the button is binding button text. So what that is saying is that whatever object the data context applying to that element, or a container element, which is the stack panel in this case, whatever data context object is pointing at that, we're looking at that object for a property called message in the one case and getting the value of that and displaying it on the screen, dummy message in this case.
Right.
And in the second case, we're looking for a property called button text, pulling that out of the data context, out of the view model, and displaying that on it, which is click me in this case. And you see this pattern a lot with the page resources. There we are declaring an instance of a class called view model. It's an object, a class we've created in our app called view model, and we've got given it a key that we can address to it, a VM. So that's why down below we've got the data context is pointing at the static resource VM. So there we've connected our instance of our view model class as the data context of the stack panel, and that's how it kind of works. That's a nice simple example of data binding, the classic data binding.
So fundamentally, there is a data context, that's where your data comes from, and you bind to the properties of that data context, which ultimately is just a class.
And the important thing about it is that the class itself that exposes the data, the view model, doesn't know anything at all about who consumes it. So we've got, in terms of software patterns, this is classical separation of concerns. The view model, its job is just to present the data view of the world, of this app, to whoever wants to be interested. And the person who's interested, of course, is our UI, and using those binding statements. So there's no code, linking the two. It's nice and decoupled and very flexible.
Not linking is the important part. This messaging between them is all handled only by the data binding.
That's right.
It's not an actual connection between them to keep them separated. That's the reason it's model, view model. It's the reason it works. It's a basic of the presenter pattern is where it really all kind of comes from.
That's right.
So we're talking about classes, right? We're just talking about view model, it's a class. We're talking about model, it's a class. Is there anything special we need to do to those classes?
Yeah, so if you think about, you just mentioned the producer model there. So actually the UI, if you like, is acting as an observer of the presenter.
Yeah.
So it's the view model classes are presenting that data out to whoever wants to consume it. But obviously the UI needs to know when anything changes in that class, which is why we use the updating the UI. There's two interfaces that are crucial to all of this, which is the iNotify property changed and the iNotify collection changed. And essentially what these interfaces are is that a view model will implement an iNotify property changed on any property on it, so that whenever that property changes in that view model class, an event is fired, and it's the UI that consumes that event.
Okay, so my UI is not polling and asks, has it changed, has it changed, has it changed, has it changed? No. That wouldn't be very performant.
No. In fact, well, the first time the UI displays, there's different modes of binding, which I'm sure we'll talk about. But the first time that when the page is first displayed, then the UI will go off and pull the initial values of those properties off of your view model. But thereafter, maybe you've got some code in the background that's going off to some cloud service or something, so that I'm pulling down some data, and then we've got new data or some processing. So the data, the view model is changing, the values of those properties is changing. So the UI needs to change in sync with that, and it's through these events being fired. That's kind of it. iNotify collection change is the same thing, but it fires events whenever the elements in a collection of objects change. So
it's not that a property value has changed now, it's that its membership has somehow changed.
Yeah. So this is classical when you have a collection of data items and then some new items get added. This is when you add some new items to that observable collection, and the collection changed event will fire, and the UI will be notified that something has changed. It can go and get the refresh data and change the UI.
So we have iNotify property change to raise an event whenever the value of that property changes. But in Windows 10 for UWP apps, we have a new ability in dependency properties to immediately register for those changes. That wasn't actually available to us before. And so now we can say a dependency property shows up in most UI elements. So I want the text property, for example, I want to know when that changes. It turns out the text property is a dependency property, and so I can register for its changed event directly. So don't even pay it. I don't care if there is or isn't a text changed event on that control. I can go directly to the property and ask when it's changed. Very powerful, very handy too.
Yep.
So the syntax for basic classic binding includes a lot of options here, and of course we lead with binding.
Yeah, that's the primary one. So that is the binding statement, and then we can apply lots of things that change to it, like the converters, for example. This is where, so obviously anything that gets displayed on the screen is essentially a string. So it's visual, it has to be displayed on the screen in some way. But what if the property of our view model is, I don't know, an integer or a double or a date time or something? You may want to take that raw value of the data value and convert it into the format that you want it to be visualized on the screen. So this is where you can use a converter, which is a special class, a special object you create that does that conversion between the translation between your view model property value and what you see on the screen.
And so I guess that converter then can have logic in it to say, if you're going to convert it into German representation, that's why you might pass in language. So you can have a specific, and then the parameter says the converter might need a little bit more information, and so I'll pass in an extra hint of some kind using the parameter.
So these value converter classes are a very common ingredient of a good number of XAML-based apps.
So element name is nice, so that allows me to bind directly to another element on the screen?
Yep, that's right. Fallback value means if you can't find a value from whatever you're bound to, use this one instead. Mode is the one-time or one-way or two-way, which basically means one-way means you just go back to the view model, get the value when you first displayed.
That's one time. So
one time.
Only at the beginning.
Yeah. And one-way means the UI will update whenever the view model property changes at any time. And a two-way is only for sort of like a text box, which is
a date picker.
Or a date picker, where you've got user input, and that needs to be communicated back again the other direction, back to your view model.
So one time is like a very cheap one-way. So one time happens only at initial read, but that two-way is that two-way data binding, the thing that makes it most powerful, really, to be able to go both directions if you want to. Very nice.
And what's this update source trigger, Jerry, the bottom one? It's not such a commonly used one.
Update source trigger, it determines, we need to read it backwards. It says the trigger for when to update the source. So the source is the model. So there's a little confusion on what's the source and what's the target. Not to me, right? The source is the model because that's the source of your data, right? That's the idea. Anyway, so when do I update my model? What's the trigger for that? I can select a couple of things. I can select explicit, which basically means me as a developer, I will invoke that. Just let me do it. It's very uncommon for that to be, right? Because you want it to be automatic. Another one is around is the default. So that would, for a text box, for example, it doesn't write back to the model until it loses focus or gets the blur event. Or is it unfocused or lost focus? Yeah. Blur, I think, is an old term. Well, anyway, the third one, and very powerful one, is this property change. So whenever the property is changing, so imagine a text box, as I type in whatever value that is, every letter writes back to the model.
And that's the common usage. This is when, more often than not, this is when you see this used, is you want to update the model as every character is typed in, rather than wait until it loses focus.
Yeah, that's right. Okay, so we were talking about converting the data. You were talking about using a converter, and that's the I-value converter. And basically, it injects in between as it reads the model and as it writes it out to the screen using the convert method.
Yeah, so the I-value converter interface has two methods in it, which is convert and convert back. And as the name suggests, one is converting from, you're taking a value from your view model and converting it for display on the screen. And the convert back is the reverse direction, where you've got a two-way data binding and you've got some kind of value that's been entered into a UI control, and you want to convert that back in a way that can be stored back in your view model.
More often than not, you'll see value converters that don't have a convert back.
Yeah, because it's usually that you're changing data in the background and you're just displaying it on the screen. So you only need the convert method implemented for that.
Yeah, that makes sense to me. So these value converters, by the way, are super powerful to make your application look the way it needs to look. But it's worth saying there's a caveat around them in that they are not free. They do have a performance cost. So using them to show a date or something inside your application is perfect. But using it to show, to convert a massive amount of data, let's say in a repeater, that list after list after list after list, you're running this over and over again, can really degrade the performance of your application.
Yeah. So let's have a look at this, shall we?
Yeah, I think so.
Okay, so here we go then. We've got a new project. We're just going to create this out now. And over here, we're going to add a class. So I'm just going to create that.
So this is the to-do item?
The to-do item in our to-do list. So here we go. Give it a public property title, and then we're going to go off into our view model. This is our main page view model. We're going to add a collection, observable collection of to-do items into that. We're going to put a bit of code in the constructor. We're just going to create 100 of these to-do items. Sample data. We're just creating those 100 examples. We're putting up values, just formatting a string into the title, so they're all going to have task title number.
A little unique, I guess, is the idea.
That's right. And then we add them into our collection. So we've now got a view model that's exposing 100 to-do items. And now we need to go off to create a new view that's going to actually consume that. So this is our page that's going to consume this. We're going to create a symbol, namespace for the getting at the view model's namespace, and then in our data context, going to create an instance of that main page view model.
Declare the view model right there in the XAML.
That's right. So we're creating it. Now here's our grid. We're going to create a column, another column, and now a list view, and we're going to put that list view into the first column of our grid. Set a bit of a header on it, some bit of text, and then we're binding the item source using a binding statement to the items property of our data context.
Oh, I see. So that main page view model was your class, and that items is the property that you made.
Yeah. Now here's our data template. So every item in the list is going to be displayed using this XAML inside the data template. And you see we've got a text block, and we're simply binding the text property to the title property of a data item, of a to-do item object. So now we should see a simple list view with 100, there we go. So we can see the header of classic and then all of our individual items displayed there on the list.
I see.
That's
So
it.
And that data template was very simple, but you could make it as sophisticated as you want, showing first name and second and last name, let's say, and
and
like that.
If you think of a typical list view, which has got kind of a lot of rich display of data in it, you'd be binding to a number of properties of your data item.
That makes sense to me.
Yeah.
That makes sense to me. Let's see. Data bind to models or data bind to elements. So I've got a demo that I think is worth showing as well that allows me to create a user interface that instead of talking to like what you demonstrated, where you create a simple view model, that was very simple, wasn't it? Very simple little view model that's a background class that gives you that data. What if instead of reading data from that, I read data from an element on the screen? So here, let me put together this demo and see if it makes sense. I think it's easier to see it. So we'll start with a blank template as well. So this is going to be template. So we'll do number 7 here. So we'll take what's already there, and I'll set it up. So what I'm going to need is a couple of things that lay out vertically. So I'll start by just a rectangle. This is what we'll kind of manipulate. And so we'll make it 100 by 100. I'll fill it real quick with steel blue. And then below it, I'm going to add the slider control. So that's nice little control, goes left to right, allows me to set the minimum and maximum. So what I'm going to do is change the zoom level into the rectangle. So I'll make it to half its zoom level or double the zoom level, and we'll make it a smooth frequency. So we'll say 0.1 will be how quickly it steps. So this is just my slider, and I give it a name because I want to reference it later, right? So interacting with it in the syntax. The syntax isn't difficult to write, but it might be easier if I use the UI here. So I'll just use the create data binding. I can select element name as its type and just drill down into my XAML tree until I finally find my slider. It'll do the rest for me here, but which property do I want to bind to? I want to bind to its value. There you go, value. And so that'll work just perfect because it's a double, and that's what I need. And so look, I have my composite transform that sets this scale or the zoom level of X to whatever the value of the slider is. I'll also do it for Y, and I'll just copy it because it'll be easier and faster. So now it's already set. There's really nothing left to do. As I make a change to the slider, it will update its value and send it off. Right? I'll give a little margin here so we can see it as we zoom it. Let me run it here. It's getting ARM, so I'm going to need to change that down to be 64. All right, so now when it runs, I'll have both the rectangle and the slider. Let's see if it comes up. There's the rectangle. So you see it's 100 by 100, and I grab and start to zoom. You can see it doubles all the way back down.
Applying a nice scale transform to that rectangle. So just by changing the value property of our slider, we can change the scale, the size of that rectangle.
That's right. So I'm using data binding just like before, but I'm not binding to data. I'm binding to an element and a property of the element that's on the screen. That's exactly right. Okay, so that's
classic, yeah.
2 pieces of binding. Really.
And the thing about, we often say that data binding is XAML's best and worst feature, isn't it?
Yeah, that's right.
Yeah, because it's a best feature in this lovely separation, a nice clean separation between your data and your UI, no horrible code to set values explicitly, lovely. But there's a performance hit with classic binding.
Yeah.
So, and so much so that first-party apps, the kind of ones that we ship out of the box, wouldn't generally use data binding because of the performance hit. But because of this new feature,
new feature called compiled binding.
Now they do.
Compiled binding, that's exactly right. What problem are we solving? We're solving the performance problem of classic binding. It's kind of neat to see some of this is a snapshot of some instrumentation around classic binding. And so what you can see is right here when your application starts, all of the binding then kicks in. And the reason, and you can see it goes all the way across here, and this is a quad processor, and so it's only 0.25%. You can see it's at 25, but the reason it's only using one processor. Well, the reason that's interesting is I've kind of maxed it out, and what it's doing is it's setting up all those listeners to that iNotify property change that you talked about. But even more importantly, it's also reflecting back into the code, because as you point it to like your main page view model that you demonstrated, it's having to reflect to find, okay, I know I'm going to this view model, but what type is this view model? Oh, okay, it's this. What properties does it have? Does it have the items property that I'm looking for? Can I bind to it? Is it the right type? Does it implement iNotify property change? And all of the things it needs to figure out, it reflects to find all of them. So that's where classic binding is actually quite expensive.
Reflection is known for being an expensive operation, isn't it?
That's right.
Yeah.
That being said, it's worth pointing out that the time frame here is half of a second. So this isn't an you're not waiting for half an hour for it to, it's there and it's ready to go. But as soon as I have a lot of binding, suddenly this becomes a kind of a growing problem where this adds to that, and I start having lagging feeling inside my application because of classic binding. But we have this compiled binding, and I'll show the syntax and kind of how it works. But what you need to know right off the bat is it doesn't use reflection. It's all strongly typed, which saves you a lot of the pain that you would get otherwise.
You get a massive improvement in your startup time.
It is a massive improvement. That's exactly right. And so instead of having this long section of what are we doing here, it knows already because I've declared it in a strongly typed way, and it's just tremendous improvement. So I can start adding more binding to my application and knowing that I'm not going to just compound a problem, but it's just going to be, it's going to behave almost as if I were coding it in code behind instead of using the declarative binding. So this is...
Yeah, this is really exciting. And XBind, compiled binding.
Yeah.
Basically, at compile time, it generates the code to wire this up behind the scenes so that you're not doing any of this runtime reflection.
That's exactly right. And of course, it's X:bind instead of that classic binding, only because X: is the indicator that this is a compilation activity. This is something that happens when it's actually compiled. And being strongly typed means that we don't get duck binding anymore. And so duck binding is just a made-up term that now has become a real term that basically means if you bind to, let's say, for example, you bind to age. Well, age could be a property of wine, or it could be a property of a person. Well, it doesn't matter. Duck binding just looks for the property of age. It doesn't care if it's wine or a person, so it works fine. Well, that's not the way XBind works. It has to be to a specific type. So you have that main page view model. That's what it actually binds to, is the main page view model. Yeah. And then we also default the mode. So this is different. The defaulted mode for classic binding is one way.
Yep.
So I'm always listening, always updating. Everything is great. The default mode for compiled binding is one time, which means at load time, it's going to listen for exactly what the change is and not listen anymore. So it's going to ask one time and leave it alone. But you as a developer could easily go in and say mode equals one way and continue to monitor any changes on the back end, or you could set it to two-way, right? Whatever it is that you want and whatever is appropriate for you.
And other than that, all the standard binding approaches, the standard interfaces, iNotify property changed, iNotify collection changed, all these kind of things, that all works just the same. This is almost a drop-in replacement. Almost.
This is almost a drop-in replacement. I think that probably makes it worth thinking about. Some of the big differences, of course, is that this type of binding, this compiled binding for XBind, is it always has a data context that's the same. So where I saw you set the data context to the view model, and then from that point forward, you're using that to go get all your property values. In compile binding, the data context is always the code behind of the page that it's on. Right? So I'm in main page, and you want to set it to main page view model. No. It's always the code behind of main page, and I can interact with any property on main page, including a property that might be the main page view model. But what I don't set is the data context.
So that's going to be the primary change. There's none of that stuff that I had declaring an instance of data of a class and directly in the XAML. You can't do that. You have to change it slightly. So you'd have to sort of inject an instance of your view model as a primary property of your code behind class.
That's right. And by primary, I'm sure you meant strongly typed property that I can interact with. That's right. So I can't use data context.
Thank you, Professor.
Because it's type object, right?
Yep.
And type object doesn't have any properties, and so I wouldn't be able to interact with that because at compile time it could invalidate it. So this is interesting around the syntax. So you can see syntactically it's nearly identical, not exactly, but nearly identical to binding, with the difference of, for example, element name. So element name, that's no big deal, because in XBinding, because the page is the data context, I just say the element that I want. So let's say I have a text box that says first name text box. I just say first name text box dot. Well, first name text box is a property of the page. And so it's easy for me to interact with an element because it's already a pre-built automatic property of the code behind. So that's missing, but it's not missing. The other is this idea around relative source and source. Well, that's because data context is always the page behind. You're not manipulating the source of the binding. And so that's important to us. But then we also have this idea around update source trigger. Remember, that's the
one
trigger
we talked about
that writes back. And it doesn't exist. And so this is a tricky thing. That means that if I use xbind in a text box, the only time that it writes back is the default implementation for binding, which is when it blurs or when it loses its focus, right? And so this is good and it's bad. It's good in part because you're not writing back to your object all the time. It's bad because it's a difficulty. I mean, honestly, it's a difficulty because you want to be able to type in whatever it is and click save and know that all these values have been written back to your model the way that you want it to. So there are some workarounds to this, but this is the general idea of what you need to know. There is absolutely a binding, there now is a bindings property to a page that allows me to say .update, and it'll update all the bindings for me. Even one time will be updated when I call that. And so we'll show the syntax here in just a second. Data templates are also a little bit different.
That's a little bit changed, yeah. So you can see we've got item source there is using xbind to an employees property of our view model, which is now a property, obviously, of our code behind.
Right.
View model is on the code behind. And then we're getting the employees, which is a collection of employee objects. But in a data template, you have to explicitly declare, it needs to know up front what the actual data type is of what is an employee object. So this is why we use this x:\data type to explicitly declare what type of object is an employee in this particular case.
x:\data type, we've never had that property before.
No, that's new.
And so that sets it explicitly so it can validate all the other bindings that are going to be in your data template. If you don't use xbind in your data template, then you don't need to put x::data type. But there's a side benefit of x::data type, and that is that you now get full autocomplete.
Yeah,
so if you have that out into a style or something, then you've got that.
And if you forget the x::data type, it will tell you at compile time. It will just say, oh, you can't have a data template.
In a real friendly way, a giant error appears. That's exactly right. You know, this is another win here is if you type the binding syntax incorrectly for the classic binding, it doesn't give you an error. It just doesn't work, right? And you can see it in your output in Visual Studio. And that's okay, I guess.
Yeah.
But this gives you a compile time binding. It can't find the property, so just like if you're writing C# code that try to access something that isn't there, it gives you type safety.
So none of this inadvertently misspelling a property name in a binding statement. You just won't get through the compile stage if you with compiled binding. So it's enforcing best practice for you.
Accuracy. Meanwhile, delivering all of this benefit around performance.
It's a good thing.
Yeah.
Let's have a look.
Right. All right, let's take a look. So here we are back in your app.
Yeah. Right.
So that's classic binding on the left.
Yeah.
Okay, there's your list view.
Okay, so here we've got, here's our header, and we're actually now going to put a new copy of that.
Compile. There you go.
There you go, thank you, yes. So we're going to copy it, but this time we're going to compare side by side with, this is xbind to the item, so it's still same. And there we say straight away we've got a compile error because
there's no items property.
There is no items property on our code behind, so we need to fix that first. So we've got this kind of hybrid example here. Now we're going to create a public property called viewModels of type name page view model. And we're going to actually hook that up to
data context changed. Okay.
Right. So there we're going to actually this is tying the old model and the new model together. So when we set data context in the traditional way, we're actually going to set that property on our code behind as well.
That's interesting.
Yeah.
So now I can still declare it in XAML the old way, but get the benefits of xbind.
Indeed, indeed. So yeah, so now we got our view model is the property on our code behind, and the items property, and so this should, if we're lucky, should work out. There we go.
I can't tell a difference.
Oh, I'm sure the one on the right actually appeared slightly. No, it wouldn't. It's because the whole page.
So small. Yes.
Yeah.
All right. So now we're going to use xbind inside the data template.
Yeah, and we go. So we're actually going to declare a namespace symbol there of
to the models.
To the models, because we need to declare the data type of each item in that collection of viewModel.items.
To-do item that you created earlier.
Yeah, this is our model item. So that's all that it needs in order to be able to resolve that xbind title inside that compiled binding. So
now everything on the right is 100% xbind.
Yep. That's
4
right.
quick steps too. I mean, you put xbind instead of binding.
You can see how it's almost a drop-in. There's a few little extra things about declaring more explicitly what the kind of the type is, but essentially it all works the same way.
Yeah.
Yeah.
Putting that code behind to be able to switch out the view model, that seemed pretty straightforward.
That was, yeah.
Then you get to use everything without any big differences. Well, here's a snapshot of the code that you just built out. And I think it's worth noticing, let's see, that when I was pointing to items, that the classic binding doesn't know if there's a property there or not. It'll test it at runtime. But when you set item source to xbind viewModel.items, it checks as it compiles, so you don't have that checking cost at runtime. So that's really the biggest part.
So if we'd spelt in the classic binding, if we'd actually spelt it binding items and put an extra S on it by it just wouldn't work, and then you would see in the output window you see a binding error, but it wouldn't fail. Whereas the compiled one, you wouldn't get it to run.
And I noticed you ran it twice, and the first time, even though you were using xbind in the item source, you weren't using xbind in the data template.
Not the first time. No, that's
so
right.
I guess you can intermix these things. It's not all or nothing.
You totally can. Although if you're going for it, I suggest you go for it wholeheartedly. And if you're going to move to compiled binding, really that's where you're going to get the perf benefits.
Update source trigger, if that's a heartburn for you, then just your text box that you interact with like that, you could use classic binding.
Yeah, you could. That would be a good solution. Yeah.
That's fascinating.
Yeah.
It really is. All right, so improve your performance with compile binding, but you can also, of course, this is as a general statement, improve your performance by simplifying your templates as well, because you can't overcome the fact that an overcomplex XAML tree really becomes an expensive thing to render. Okay, so let's talk about resource dictionaries in the context of compiled binding. It's different with compiled binding. First of all, you have to specify the class. We never did this before because there never was a code behind for a resource dictionary like there will be.
So now we actually have to have a code behind for a resource dictionary, which is a brand new thing. Because we are compiling this into C# code, it's not just a XAML resource that we're pulling in and evaluating at runtime. It's much more than that.
Obviously, this means that you would only have to do this on resource dictionaries that implement xbind somewhere in them. But just like anything in XAML, once you have this, you must initialize what's inside it as well. So once you have that code behind, don't forget the one most important line.
Initialize component.
Yeah, no doubt about it.
Yeah.
And so that's how I bring. Now this class, by the way, has to do with the resource dictionary. It has nothing to do with the data template. It's the resource dictionary that includes a data template. So what that means is this is not the code behind for your data template. This is the code behind for your resource dictionary. Big difference, right? We don't have code behind for data templates yet. That's something that the team is working on, and we'll see shortly, I'm sure. Okay, so I talked about this before, but just as a reminder, we have bindings.update that can cause all your bindings to refresh themselves, and that's really valuable. Another piece we have around resources, and how do I reference that resource that you just created? I don't reference it by source. I reference it as if it's a class. This is very similar to the syntax that you used when you referenced the view model inside and declared it. Now you reference it just like a class.
So that local colon. So the local is the namespace, and what you're effectively saying is instantiate an instance of my templates.
Yeah.
It's a class like anything else now.
Yeah, that makes plenty of sense. The other use, so I want to go back to update for a second. Another thing you can do is for asynchronous data. This is kind of a gotcha that compiled binding kind of brings is it's possible for the data that you're loading to not be ready at the time that it's rendered first. So the UI renders, meanwhile your data is collecting, finally it's available, but it's still not showing up because it's one-time binding. There
could be some async await stuff going on, and your data has been retrieved from, I don't know, a database or the cloud or something, so there's a delay before it's available.
So now bindings.update has another value of saying, refresh everything because I just got fresh data.
Yeah, it's kind of, hey, do your one time all over again.
Right. That's too complicated for you. Just switch it to one way instead of one time and things are good. Another cool thing is I can bind for events. So right now, you know that you can say click equals, in this case it's poke employee, and that calls to an event that has the same signature as click, right? Well, that's great, but what if I wanted to have a method that I called that was inside my view model? Well, now I can xbind directly to it. So I can say click equals xbind employee, let's say that's my view model or my model, either one, dot poke, and now poke represents not a property because it's a click event. I'm binding inside an event. It represents a method that can have a couple of signatures. It can have an empty signature of no parameters. It can match the parameters of the click event or whatever event you're using, the routed event that you have. Or you can go all the way back down to the base of just object-object. So you don't remember what it is, that's okay.
Yeah, you can just
use object-object.
So this is a lightweight alternative to commanding, which some people may be aware of as a way
That's right. It's a quick and easy way to do commands without having to build out a delegate command.
Yeah.
With the downside, of course, is you don't have the can execute, which disables the button when it's not allowed to execute. Actually, that is the thing. That's the biggest.
That's the big difference.
That's
so
how
it's just a lightweight core, but without the nice things you get with command about being able to easily disable buttons and things.
That's right. Then there's also stop tracking. So bindings.stop tracking, I can pause all bindings. And how powerful is this? I need to make all kinds of changes to my UI, and I don't want it to agitate all the bindings. So just freeze the bindings with stop tracking, and then I can start them again when I'm finished.
We used to have something like that in Windows Forms.
Yeah.
It's like suspend, suspend update, and resume
also
update.
In WPF. Yeah. Very powerful. All right, some common scenarios that hit people. How do I do relative source like self or element name? Well, remember, because the code behind is the data context, you just call element name by their name. You don't have to say source or element name equals like we did in the early sample. And then relative source and template for templated parent, those simply don't work. That's not an element here. We're seeing whether or not they'll come into xbind or not in the future. But don't forget that templated bindings or template bindings are already optimized. So it's already in a pretty good spot there. And then don't forget update source trigger. The solution might actually be just to use classic binding in that one instance. And then what do we do with source and data context? Just make a view model property. And just like you showed, it seems so simple. Just make sure you're using the data context changed and set it as soon as it is. That's really nice. Really nice and clean too.
Nice pattern for doing that.
That's right. All right, this is as a reminder, this is how we did it. Data context changed and just set it. Nice and simplistic, to be honest. All right, and finally, let's remember that xbind is not for every situation. There are a few deltas here and there that make it maybe so it doesn't fit your needs yet, right? A lot of investment is going into the compiled bindings. Soon it will be a one-to-one match for availability. And so the things that you need to make it work will be there. So
it's pretty complete, but yeah, they're still working on it.
I would say like 80 to 90% of all use cases are covered already. Yeah. And from here and there's a couple of things that you need to kind of touch on. That's perfect. When classic binding just makes sense, sometimes duck typing is right? Sometimes you don't know if it's wine, sometimes you don't know if it's a person. So you got to use a.
You might want that decoupling, so you just want it like, a duck is a duck. So if it sounds like a duck, looks like a duck, it's a duck. That's what it is.
That's right. And duck typing also enables us to bind to something like JSON, which JSON has no typing at all, but we can just say, I want to use this variable or this value or property, and it just works because now classic binding does all that reflection for us behind the scenes. It's expensive, but it's powerful. But with great power comes expense, I guess. I don't know.
Responsibility.
Code behind binding. If I need to add and remove bindings on the fly, the only way I can do that right now is with classic binding. I cannot do that with xbind. So that's okay. I just use classic binding, but that's another time to use it. And if I need it in a style for some reason, I'll do it the same way. Xbind it meets your binding needs most of the time, right? Let's just say it's way more than half, and it's certainly less than 100%, but it's really, really up there and gives you so much value back. Yeah. If binding is killing the performance of your application, maybe you need to start looking to xbind. Honestly, look into xbind anyway. There's so few scenarios where it doesn't work. You probably could replace it with just a giant text find and replace.
Yeah, and it's worth saying, I think, that if your app is not particularly complex, the UI is not particularly complex, then obviously compiled binding isn't going to give you a noticeable improvement. So, but much more any app that's got a complex UI and that's binding a lot of stuff, and it's amazing how complex it can get once you start adding loads of functionality.
So that's the basic as far
definitely
as
going to give you
function and syntax of binding.
Yep.
It's still the same no matter which approach you choose. There's a lot of functionality now in compile binding thanks to what we've introduced here for Windows 10. And I think the developers need to just look at it and start feeling it out and realizing all the benefits they give, because a nice performant application is a good user experience as well. That's the end of this module, Andy. We're going to take a break here.
Bit of a break.
Come back in a few minutes, talk about something else.
All right. See you soon.